Good morning, class. I just want to start off with a recap of what we've already talked about. You learned about two types of energy waves, mechanical and electromagnetic. And you learned that mechanical waves can propagate energy transversely or longitudinally, whereas electromagnetic waves can only propagate energy transversely. So we're going to study the parts of a transverse wave as well as the characteristics of a transverse wave, and then we'll do the same for a longitudinal wave. There are three major parts of a transverse wave, as you see on the screen: rests, crests, and troughs. A rest is basically, it's an imaginary line showing where the medium or the particles of the medium would be if no energy wave was disturbing it. The crests of a wave represent the highest distance away from its original position that it would be disturbed when the energy wave travels through it. And a trough is the lowest point that a particle would move when the energy wave travels through it. Make sure that you're recording these three locations on the diagram on your notes. Next, we're going to look at three characteristics of a transverse wave, and those are amplitude, wavelength, and frequency. Make sure to also label these on the diagram above where the characteristics of transverse waves is located. Let's talk about amplitude first. Amplitude is a distance. It can either be the distance from the rest position to the crest, or the distance from the rest position to the trough. And both of those distances are equal to each other as the energy wave moves through matter. So make sure that you show where on your diagram on your notes where the amplitude is. The amplitude, again, should be a distance. So you're drawing it with arrows representing from the rest line to the crest, or from the rest to the trough. The amplitude is important in a wave because it helps us understand how much energy the wave is transporting. So the greater the amplitude, like the wave on the right side here, the more energy the wave is carrying. And this would be true with seismic waves if you were talking about earthquakes, ocean waves, etc. Next, we're going to move to the second characteristic of wavelength. Wavelengths are also known as cycles. A wavelength is the distance between two crests or the distance between two troughs. Or really, you can measure it between any two of the same points. Let's look at a couple drawings down below before you draw yours on your paper. You can measure it from crest to crest. The problem is sometimes you may not have two crests. Here on this diagram we have one crest, but there is no other crest, so that would make it difficult. However, in this diagram, you can measure from crest to crest. You can also measure from trough to trough. Lastly, or not really lastly, but one other way you can measure is from when it crosses the rest position going in the same direction. So here, the wave is traveling upward when it crossed the rest position. So is this one. So over here, this would represent the length of one wave. Okay. Another way you can think about it is if you find two identical points. So here I have a point, and if I go straight across, I have the same point over here. That would also represent one wavelength. On your diagram, you can measure, or you can show at least a few ways to measure wavelength, just so you remember there's more than one option. The last characteristics of a transverse wave is frequency. Frequency is the number of wavelengths in a certain length of time, and usually that time is 1 second. And if you measure the number of wavelengths in 1 second, then you are measuring in the unit of a hertz. The greater the frequency, that means the greater the force was that started that wave. So you can think about that with earthquakes or ocean waves. But the greater the frequency, meaning the number of waves within a certain time period, means the greater the force. Try not to get amplitude mixed up. Amplitude is the greater the energy the wave is carrying, the greater the amplitude. Frequency is the greater the force that starts the wave, the greater the frequency. Here below, you can see that the wave on the bottom is a 3-cycle wave. So this arrow represents 1 second in time in both diagrams, but in the top one, there is only one complete wave, or one complete wavelength, or one cycle. In the bottom diagram, there are 3 waves within 1 second. So not only do we know now that the frequency is higher, but also that the force is greater that started the wave. Moving on, we're going to start talking about longitudinal waves now. And I think you've seen a couple different drawings of longitudinal waves. I just want you to take note of the drawing here, which does show it drawn with lines instead of circles. And I do prefer this one when you are trying to draw it, so I can tell exactly what you are trying to represent. There are 2 parts of a longitudinal wave. One is a rarefaction. And you can see here, rarefaction is when the medium is actually spreading apart from one another. Okay? It's when the particles have been separated the farthest as the energy wave moves through. And compression is the opposite. It is an area of particles that have been pushed closer together as the energy wave moves through. Make sure to label these on your notes as we discuss them. So right now you should have both a rarefaction and compression labeled. We're going to move on to characteristics, but I am going to flip back to the last screen so that we can use those lines to really measure. The first characteristic we're going to study is wavelength. Wavelength, again, is the same as we heard before when studying transverse waves. It is the distance between the same parts along a wave. So when you're talking about this, again, you can measure from the beginning of one compression to the beginning of another compression, and that would be one wavelength. You can measure from the end of a compression to the end of another compression. You can measure from any of the same 2 points, and that will work. Lastly, we're going to talk about frequency. Frequency is measured the same way in a longitudinal wave as it is in a transverse wave. In the drawing below, again, it's a little difficult to make sure that we know exactly how many waves are there, but I can see here that there is a beginning of a compression. So if I measure and keep that the same, then it would be 1, 2, 3, 4, 5, and maybe a little half if I add this on, plus the beginning over here. So about 5.5 waves. If this picture represents 1 second of time, then I could say that the frequency was 5 hertz. Now, you can see below that there are a couple different websites. The first one kind of shows you some characteristics of waves with animations, and the second one shows you something similar but more with water as the medium. So good luck in your studies.